Hey everyone, for folks that don't know me, my name is Michael Cole. I'm the one that's been working with Jared and others at BLM as well as Avery at DNR to put together the seasonal habitat models for sage grouse. This is part of the large-scale HAF process. Most of you probably will recognize me from meetings, what have you. Anyway, I understand there's been some questions with the review process with the new models, why we have them. And things like that. And so what I'm hoping to do is go through a quick, maybe 15-20 minute video of just kind of walking you through some of the things, how do you review the products, and why are we doing this, things like that. Let me pull up a few things here so that I can make sure I check off a few of the boxes, what people were interested in. Let's see here. And so I'm going to do this through a webcam rather than a shared screen, so I can kind of point and click and you can see me occasionally and things like that. But we'll go through it. So, all right. So the first kind of question is why there was a new modeling effort taking place. So if you're aware, we had kind of the historical seasonal habitat models. DWR had their own, BLM had their own, Forest Service had their own. About two to 3 years ago, we put together what we've been calling the interim map. I can pull up a variation of that, but you guys have probably seen it. It's available on the web. And it was broken down into winter, breeding, and summer habitat. The reason we haven't used that model and just called that good is a number of issues. We'll talk through them as we go through here. But generally speaking, the big picture thing is that that model was entirely built off of VHF data. Now we have a great VHF data in Utah, a data set. It goes back to 1998, and there was about 15, or I want to say, nest. There was maybe close to 1,000 nest locations in that data set, and then there was maybe 20,000 VHF location data sets. So it was a really good data set to work off. The problem is that because of how we monitor sage grouse in the field, and because it was VHF data, it was really biased. And by that I mean we were skewing toward reproductively successful females. So most of our collars were almost always going out on females. And because of time constraints, field constraints, things like that, we'd follow all the females, see which one they nest, and then if they nest, the ones that didn't nest, we wouldn't monitor as frequently. But the nesting hens, we would monitor, at least every 2 to 3 days, and then wait for the nest to hatch. When the nest hatched, we'd follow that brood. If the nest failed, we wouldn't necessarily follow that hen. So really what ended up happening is a lot of our data was really only being collected on the females that successfully were initiating a nest and then hatching a nest and raising a brood. That being said, we also didn't collect much winter data. And so you can see that we don't know much about non-reproductive females. We don't know hardly anything about males in this model. We don't know anything about the winter habitat models. That was one of the primary reasons that we needed to extrapolate our data set, which is where a lot of the GPS data comes at. I'll show you a little bit of that data. And then from there, we can use that to model across seasons, across all individuals, males and females, regardless of reproductive success, and also incorporate data from some study areas, some intense data collection that we haven't really had. So a lot of these VHF studies that we've done in the past were like a 2 years master study. And so it was a very short window. This gave us a lot more data rather than say 1 year of data, 2 breeding seasons of data for a given SGMA, for example. So that's kind of the big picture. Now, I know there's been some concerns that the models that we have now are over exaggerating some of the seasonal habitat quality, and we realized that. We knew that right away as soon as they came out. There's a couple reasons I'll walk through why that happened, but I want to make sure people understand it's not. It may appear like a step backwards, but this was kind of what we just sent out in July is more of this was the first step. We want to make sure that you guys had a chance to provide us feedback. So as we're making a few of the corrections that we know needed to be made, we made sure that they were matching up with exactly what you guys are seeing. Now, to make your guys' life more efficient, what I'm actually going to have you guys do now is actually providing additional feedback on those maps from about 2 or 3 years ago. For me, it doesn't matter. What I'm trying to do is put up a map of For example, if I've got my 2 computer screens here, I can put a map up over here of what you guys say in the field is good habitat quality, and then I can look over here and say, okay, so this is what our models are saying, how well do they match up? So it doesn't matter to me what exactly those what map you guys make comments on, because I just need something to compare to what our models are building. And then we'll talk about the other reason that, as we go through it a little bit, as to why the models aren't performing maybe as you guys would think they would be, or maybe they're over-exaggerating areas. So I'm going to focus on this screen here. Hopefully there won't be too much of a glare on it. But we've got our state of Utah. We've got, I'll just use the SGMAs. You guys are all familiar with those. They're relatively close to the PHMAs. Now, give you an example. Here was the a variation of the seasonal habitat map that you guys would have had. What you guys would have seen. There was 7 different color combinations. They all represent different things. They could represent just nesting, just breeding, just summer, or they could represent summer and winter, or I mean summer and breeding, or breeding and winter, whatever. So all those different combinations, that's what they work out. But if we just grab one of those, that would look something like this. So this would be the breeding model from that model you guys saw about 2 or 3 years ago, the interim maps. We'll zoom in. Let's just focus on box elder for now. You can see, let me add a base map here so you guys can kind of see what we're dealing with. But you can see it's capturing very closely to really a lot of the SGMAs. See if our internet is fast enough here or not. I guess I should have loaded this one earlier. Okay. All right, so we can see that a lot of this is considered nesting habitat, except on top of the Raft Rivers, some of this open country, and on top of the Grouse Creek Mountains. All right. Now, in comparison, to give you a sense, because I know the box elder is one of the areas that people are having issues with, this is what our final map picked up for box elder. Now, the first thing to notice is that the other thing that's important to note about these maps is that we are extrapolating beyond the Utah border. This is important for BLM particularly because they're trying to get all their maps to meet up with adjoining states as we do this range-wide national analysis with the BLM. So our maps will go past the border. They actually go quite a bit further. For this part, just for simplicity, what we did at this point was actually only say we're only going to go within 5 kilometers of a PHMA or a SGMA, just to make life consistent. With the final products, that actually won't occur. That'll go with all the data, so we'll actually know, if there was maybe some habitat down here. We know there's occasionally some birds that get seed maybe down in this country here. I don't know if you guys will be able to see that quite well. My mouse. Let me try and make my mouse bigger. Display settings. Mouse settings. There we go, cursor size. All right, we're going to do perfect. Okay. All right, so now you can see my mouse up here, so you guys can see where I'm focusing my clicker at. All right, so you can see there is quite a difference. The other thing that people have noticed that it does extrapolate quite a bit further. We'll talk about that in a second. All right, so hopefully, first question, why did the modeling effort was initiated? Like I said, it's because we had some bias in our data, so we needed to incorporate new data. Also, the VHF data, as I said, was primarily biased. That's the reason for the data. Why not just analyze it the exact same way? That's because what we're trying to do is incorporate some new spatial data that only became available in the last year. This is data put together by the Sage Grouse Initiative. The folks at the University of Montana are the ones in charge of this, but they're taking NRCS, they're taking AIM data, and so the BLM veg sampling and the NRCS veg sampling data. So it's all been ground truth. They're basically building a sage grouse range-wide model for plant community composition. So percent shrub, percent tree, percent grass for bare grounds. and there might be one other. I think there's six ecosystem vegetation communities. The reason we want to go to using that data over what we've done in this previous mapping is that it's annual measurements and it's ground truth. So what went into the interim maps is actually just a land fire vegetation data. And so if people are familiar with that, that's a product that's built across the United States, but it's only ever built anytime the Congress gives appropriations to do it. It's supposed to happen every 2 years, so it happened in 2008, 10, 12, and 14, and it hasn't happened since. So right now, any vegetation data that we're using is already 5 years old. Now, that's really problematic for sage grouse because we're doing so much PJ conifer removal in the state, and so we're transitioning very quickly tree cover to shrub cover, but that's not capturing our vegetation layers, and that's a big problem when we're talking about modeling habitats of sage grouse. The other issue is we know spread of like invasive species, particularly cheatgrass, is a big issue, and so if we're not able to capture that at an annual cycle, we're really missing the boat. And then lastly, we can do things with these annual maps, like think about different wildfires during the summers that we can't capture with the old land fire data unless we go in and manually do everything and point and click in areas and say that this was a fire, this wasn't, and really manipulate layers on our end, which isn't very efficient. And it also means that we can't compare our vegetation layers to, say, Idaho, Wyoming, etc., because they might be pointing and clicking on their maps quite differently. All right, so that gives you a sense of why the effort hopefully was initiated to do a telemetry bias and also to incorporate these new vegetation layers that will hopefully make our product much better. All right, so as you can see, the black was the original interim map. The red or pinkish color here is the newer version. And one of the things we knew right away when we did this, we tried to do one step that was accommodating variation in habitat quality. So we didn't want to compare box elder to, panguitch and things like that, because we just know the habitat quality and vegetation conditions are so much different. When we went down that route, what ended up happening is we didn't quite have enough data for a few study areas, particularly like the Parker Mountain area, because how the vegetation, that black sage is a very small area. We don't have a lot of GPS data in that. There were some other reasons, but that's the primary one. We couldn't originally do that. So what we went to at this stage was a statewide map. It's exactly the same scale then, in essence, of the interim map. So both of those are statewide analysis. But what we're hoping to do on this next iteration is that we'll actually be able to lump things into the WRI, which correspond to the DWR sage grouse region. So basically, like box elder and Rich County will be compared together. The southwestern populations will be compared together. So we're actually comparing apples to apples, not apples to oranges. All right. So that being said, that's one of the things that we're going to be incorporating. So why? But given that this is a range-wide map and we're incorporating this new vegetation layer, the thing that really led to the first kind of difference between these two, especially when these things go out into these greasewood flats, was that land fire is able to pick out a thing and says this is sagebrush or this is not sagebrush. The new vegetation layers are actually calculating percent shrub cover. That means it's grabbing everything from green shrubbery, sagebrush, black sage, but also greasewood. And so a lot of these salt flats are actually being captured in that model. Now we have a workaround that we've developed that we're working on currently that should basically mask all that out. We were because we got pushed back in this and had to do a statewide model initially. That's one of the reasons that we weren't able to do it when we first sent this out for review, was just we wanted to get something to you guys. In hindsight, we probably could have done that a different way, and I apologize for that. So that's the first issue, is that there's greasewood in here. We know how to take that out now. There's a couple different ways we can work around that and mask that out, basically. The question was like, well, if it's calculating greasewood, why do we want this vegetation layer? Well, like I said, we're able to get this at an annual level, but also it gives us a lot more information on habitat quality. Rather than just saying this is sagebrush or it's not sagebrush, ones and zeros, this is saying this is 25% sagebrush cover, or it's 0%, or it's 65%, or it's all of a sudden allowing us to really evaluate the quality of the habitat and actually make management decisions that are directly related to site conditions. So that's why we're going to that layer. We're the first group that's using this vegetation layer at a large scale and using the raw data. So there's going to be a little bit hiccups for it. That being said, the long-term capabilities of it and the benefits greatly outweigh these small headaches right now, because we have annual maps, because we have percent habitat quality, and because we can do certain things down the road as with this as a base layer that we just wouldn't be capable of, like making adaptive management decisions. We're going to do treatment in site A versus site B, not because it's sagebrush and not sagebrush, but because we know this is 20% sagebrush, this is 12% sagebrush, but the 12% could go to 45%. That capabilities greatly outweighs this small delay and headaches that we're dealing with right now, at least in our opinion, and from the science side of it, and helping you guys do better management on the ground. All right, so what stage of development is this in? Like I said, we've given you something in the summer that kind of is that interim kind of product. We're hoping to give you a very, very clean version by around Christmas time, or give that to DWR and give that to BLM around Christmas time. The plan is over the next couple of years, there's a few things that might tweak these, but that's just because of some other data that's slowly becoming available with this veg layer, and because we want to improve it. But for big picture stance, basically a workable model by around Christmas time that will really be kind of the one map to rule them all, if you will. That's going to be the Forest Service, the DWR, and the BLM maps. All right, so what is the difference of the data used in the 17 and 19 models? I think I covered that, mostly VHF versus GPS, just to give you a sense. We'll zoom out here, turn off the base map for a second. Oops. And it's going to be really hard for me to figure out which button I'm clicking with this big of a mouse. Let's see, let's go to state of Utah. All right, so we're zoom in. I'm going to take off. Well, we'll just work with the 97 or 2017 map right now to give you a sense of what the GPS data looks like. It's going to start populating here. There's going to be some random points out here. These are actually cleaned up in the actual analysis. But this was the raw data set that basically went into the model. To give you a sense, after we clean up everything and make sure we have enough data for every bird, we were around about 480 birds that we had GPS data for, and then we had, when we extracted their nests for the breeding habitat model, because we're only thinking about nesting habitat as terms of breeding. In that case, we had over 1,500 nests across from 1998 through the breeding season of 2018. So we have a massive data set that we're able to do this analysis with. You can see that we really are capturing pretty much all of our study areas. The one place we don't have some data is Ibapaw, and we don't have, we have some gaps here around the Uinta Basin and things like that of where data may not be. But generally speaking, we have plenty of data across our major kind of regions, so the North region, the Uinta Basin, the Sheep Rocks, the Southwest, to actually think about this in terms of what do Southwest birds do and select for. And that's really all we're considering. Do we have enough data in each of these areas of sage-grouse populations? The other thing to be aware of is you'll see, maybe we don't have data in some of these places that are being predicted as nesting habitat. That's the value of doing this resource selection model, because we actually can take the data we have and extrapolate it to the birds that we didn't have data for. Now, the previous version, which is a little bit different in principle and analytically, but it still does that same thing. So that is important to note, is that we're taking the data and extrapolating it to the rest of the population. That's the value of a model versus just looking at raw data. All right. Explain why the 2019 model includes a larger area and seemingly less useful in 17. I think I explained that. A lot of this has to do with the greasewood and how we're going to be able to mask that out. And then hopefully that'll clean up the models. The second part that'll really clean up the models is when we get away from the statewide model and go to a region-specific models. That'll allow you to compare apples to apples. The other thing that's really cool about doing it that way and useful for you guys on the ground is that by tying it to WRI regions, we will then be able to directly tie the funding sources to the project prioritization. So when you say we've got money to do 6 projects in the northern WRI region, when you're thinking about it in terms of sage grouse, all the sage grouse relevant projects are directly comparable because they're they're comparing that apple to apple thing. All right. All right, so what is the intended use of the seasonal habitat models? For right now, this is just guidance on demonstrating where we should have birds by seasons. I don't think there is necessarily a ton of policy implications per se, in the sense that this isn't going to change PHMAs or SGMA boundaries anytime soon. But in terms of the actual use of it and the policy implications, that's a better question for Jared and for Heather and Avery at DWR, and they can provide you context for that. Right now, I mean, the primary goal of this is that we are trying to build one model that Forest Service, BLM, and DWR are all comfortable with, so that when you guys are out in the field collecting data, it doesn't matter what jurisdictional boundary you're on, you're working off the same designations. That's our first and foremost goal, is to make life more efficient across jurisdictional boundaries, both for the benefit, efficiency of the management, but also just for the benefit of the conservation of the species. All right. All right, so provide examples of spatial scale of feedback. Okay, there's one thing I want to allude to, and this gets at this. So the example of spatial scale. So what we've done is there's a very other important distinction between these models. The 2017 model was a binary model. This is either nesting habitat or not, or winter habitat or not, or whatever those combinations are. The resource selection model that we're working to is actually a probability. It's from 0 to 100%. So 100% being, if you went out there, you're 100% confident that if you stood there long enough or you sampled that kind of general area, you're going to find a bird. The binary model broke the data at 85%. So when I mean that, it says that, okay, if it was in nesting habitat according to this, so if we go in here to box elder and it was in a black spot, that means that these black spots correspond to 85%, or that correspond to the same type of landscape that 85% of all of our sage-grouse locations were found in. And so in essence, you can think of this kind of as like the 15 to 100 percentile. So this is basically 15% habitat quality and up. So that's useful when we're just thinking about it's in habitat or not, but it really is less useful when we're thinking about these things like applied adaptive management, where we say, okay, we want to improve habitat quality. Well, doing it here versus here may not tell us much because they're both nesting habitat. But as soon as we have a probability, and this is 10% and this is 20%, well, this one can go to 40%, but this one can go to 60%. So all of a sudden, that actually moving to a continuous value is actually going to give us a lot of capabilities in terms of the best benefit for on-the-ground management. All right, because of that, the scale that we're asking you guys to interpret at for right now, it doesn't matter that those probabilities are there. Just to make you guys' life more easy, all we want you to do, and like I said, we're going to use the 2017 maps because they closer match what you guys are seeing on the field. All I'm hoping, and these are at 1 kilometer blocks to make you guys' life easy. The final products will be in 30 meter raster pixels, so we'll have really fine scale data. For this idea, like I said, where I want to have you guys' map up and then my map over here just to compare, I don't need to know super fine scale stuff. So that's why the 1 kilometer, and you could basically say, you could go in here, print these off or whatever for your study area, and you maybe could, let's see if there's where's the draw tool at? Well, here I can, you could say, oh, well, we're missing we're missing this big round chunk right here, and you could just draw on that, make a comment, and provide it to us, and so that I know, okay, so when the model gets built, I want it to be able to capture that the sage-grouse are actually going out here, and maybe they don't go in here. Maybe there's supposed to be a gap, like we have no data there. Maybe there's no data there because there's no birds there, and so. By and large, I felt like from most people's comments that these models were doing pretty good. This is the point where you can really drill down into them and see, like, yes, this needs to extend out on this island a little bit more, things like that. Or you can just say this feels pretty good at this scale of 1 kilometer. So that's what we're really looking for, and do it for the 3 seasons. Now, to be aware, the other thing that's a little bit different between these models, but for this sense, it doesn't, or it may matter in how you're thinking about drawing those dots on the map, is that we need to think about this in terms of what they capture. So in our resource selection models that we're building, when we say breeding habitat, we're talking about where the nesting habitat. We assume nesting habitat is around lek sites, and we assume that that's the best quality habitat. So we're only evaluating nest locations. For summer habitat, we went through and looked at all of our nesting reproductive data, and we've actually figured out the exact calendar dates that correspond to breeding seasons in Utah. We're using that calendar window, not necessarily the HAF model calendar windows that were sent down as part of the Stiver document from Washington, D.C. We're using this specific to the breeding season for sage grouse in Utah, which we think is more useful. And then for winter season, what we're doing is we're using the exact same dates that the DWR and the BLM have designated as winter habitat. And that's slightly different than the 2017 map, which was offset a little bit. So we moved our data calendar to meet you guys' management plans. All right. All right, so facial scale. Will there be another opportunity to look at the layers in more detail? I believe so. I think so. If it'll be with the on-the-ground biologist versus will it be with more of the administration of DWR, Forest Service, and BLM, that I'm not sure of, but I'm happy to have that conversation with people. I hope, just to give you a sense, I want to do one thing here. I'm going to take off the points and just show you, because like I said, I think this is, I really want to demonstrate what the value of this is. So to give you a sense, let's take this off. This is what we were dealing with previously for land fire data. It was either sagebrush or it wasn't sagebrush. This is the capabilities that the new model gives us. And the color schemes are representing different things. This is all of the different data wrapped together. But from that, we can extract out the shrub layer. And so to give you a sense, so in this case, high shrub cover is in the darker brown. The green is the low shrub cover. Don't worry about the lake here. This is probably capturing some greasewood and things like that. But, you know, the east-facing side of the Grouse Creeks on top of the Raft Rivers, it's capturing things that probably aren't sagebrush, and that's the part that we're dealing with right now, and it's been led to complications. But if you can envision, let's think about this part that we know that's in that Park Valley area, and we know is actually pretty good habitat. It's a lot of sagebrush. Just look at that when we have, like, say, we have this riparian corridor through here, and compare that. We're capturing it, and we're generally capturing the same quality of stuff, right? This is all sagebrush here. But like I said, the difference is now we know that this pixel right here is, I need to get to the right layer. We know that this pixel is 21% sagebrush or shrub cover, 26. It's not yeses or no. That's what gives us the capability. And plus, we can do this for every single year, and it's going forward. And we also can go back to time. This data starts in 1982. So we have long-term trend data to think about things like our long-term sage grouse data, but also climate change, forest fire type predictions, things like that. So with that, hopefully that guy kind of gives you a clue of why we're doing what we're doing. I'm going to pop up. So I'm not in Utah. I've recently taken a position at the University of Georgia, but I'm still working with everybody on that. I'll just pull up this last slide. If you guys have questions, this will have my new contact information on it. Here's my new email, michael.cole@UGA. It's the same thing email you guys have seen, except instead of USU, it's UGA. My office phone number. So if you guys need that information or you have more questions, feel free to contact Jared or Heather or Avery, or contact directly with me or Dave and Terry at USU, and we'll see what we can do to help you guys out. Hopefully this was useful, and if there's more questions, please let me know, and I can probably put together a supplement one if there's a few things that we're still running into that are problematic. All right, thanks, guys.